Download this code from codegive.com, link in the description below. Resolving read-only file systems, a comprehensive guide. A read-only file system is a file system that can be read from, but not written to. This can happen due to various reasons, ranging from unintentional user actions to underlying hardware or software issues. When encountering a read-only file system, attempting to write to it will result in errors, often hindering normal operation. This tutorial provides a comprehensive guide to understanding, identifying, and resolving read-only file system issues, with practical code examples. Understanding read-only file systems. Before diving into solutions, it's crucial to understand the root causes of read-only file systems. Common reasons include user error, accidentally mounting a partition with the read-only option. File system errors, corruption within the file system can force the system to mount it as read-only to prevent further damage. Hardware issues, faulty hard drives or storage devices can cause the file system to become read-only. Insufficient permissions, the user account lacks the necessary write permissions to the file system or specific files/directories. Full disk, the file system might be completely full, preventing new data from being written. Write protection switch, SD cards, USB drives, a physical write protection switch might be enabled on the storage device. System level changes, security updates or system configurations can sometimes alter file system permissions. Kernel bugs, rarely, bugs within the kernel or file system drivers can lead to a read-only state. 2. Identifying read-only file systems. The first step is to accurately identify which file system is read-only. There are several ways to do this. Attempting to write *. The most straightforward method is to simply try writing to the file system. If you receive errors like read-only file system or permission denied, it strongly suggests the file system is in read-only mode. B. Using the mount command ***. The mount command displays currently mounted file systems and their options. Look for the read-only option associated with the problematic file system. Example output **. In this example, /home is mounted as read-only, ro. The errors equals remount ro option further indicates that the file system was automatically remounted read-only due to detected errors. See checking /proc/mounts **. The /proc/mounts file contains similar information as the mount command, but is generally used by programs that need to parse mount information. ddf command, disk-free. While not directly identifying read-only, the dfh command can help pinpoint if the file system is full, which can manifest as a read-only state. If avail is 0, the file system is full. Examining system logs *. System logs often contain valuable information about file system errors or remounts. */var/log/syslog, Debian/Ubuntu. */var/log/messages, Red Hat/CentOS. *journal, Systemd systems. Search for keywords like read-only, remount, FSCK, or the device name, example /dev/sda1, in the logs. 3. Resolving read-only file systems. Once you've identified the file system and potentially the cause, you can attempt to resolve the issue. The appropriate solution depends heavily on the root cause. Remounting the file system in read-write mode. If the file system was unintentionally mounted read-only, you can try remounting it with read-write permissions. 1. Identify the device * from the mount output, identify the device associated with the file system, example/dev/sda1. To remount with read-write * use the mount command with the remount RW option. If that doesn't work, and you know the underlying device. Example **. If /home is mounted read-only as /dev/sda1, you'd use 3. Verify * check the mount status again with mount grep/path/to/mount point to ensure it's now mounted RW. Important notes **. This only works if the file system is clean and doesn't have errors. If it has errors, the kernel will likely automatically remount it read-only again to prevent further damage. * Using sudo is crucial as mounting requires root privileges. Be running a file system check, FSCK. File system corruption is a common cause of read-only mounts. FSCK, file system check, is a utility used to detect and repair file system errors. 1. Unmount the file system * before running FSCK, the file system must be unmounted. Important * if this is the root file system, you cannot unmount it while the system is running. You'll need to boot into a recovery environment, example a live CD/USB or recovery mode. To run FSCK * use the FSCK command with the device name. * replace /dev/sda1 with the correct device. *y option * this option automatically answers yes to any prompts from FSCK to fix errors. Use with caution, as it can sometimes make things worse if the errors are severe. If you are unsure, omit the Y and carefully review each prompt. *F option * forces FSCK to check even if the file system appears clean. This can be useful if you suspect underlying issues. *V option * verbose mode, provides more detailed output. Example, for ext4 file systems. This explicitly specifies the ext4 file system check, forces checking, answers yes to prompts, and provides verbose output. 3. Remount the file system * after FSCK completes successfully, remount the file system. Or, if you unmounted root, reboot the system. 4. Verify * check the mount status and try writing to the file system. See addressing a full disk. If DFH shows the file system is 100% full, you need to free up space. 1. Identify large files / directories * use tools like do and find to locate the largest files and directories. 2. Delete unnecessary files * carefully delete any files or directories that are no longer needed. Be extra cautious when deleting files from system directories. 3. Empty the trash * don't forget to empty the trash/recycle bin, as deleted files are often moved there instead of being permanently removed. 4. Compress files * consider compressing large files that you need to keep but rarely access. 5. Log rotate * ensure that log rotate is properly configured to manage log files. Large, unrotated log files can quickly fill up a disk. D. Checking hardware, hard drive errors. If FSCK consistently reports errors, or if the problem returns frequently, it could indicate a hardware issue with the storage device. 1. Smart monitoring * use smart, self-monitoring, analysis and reporting technology, tools to check the health of the hard drive. The smart command is a popular choice. Look for errors or warnings in the smart output. Pay attention to attributes like reallocated sector count or current pending sector count, which indicate potential drive failures. 2. Physical inspection * visually inspect the drive for any signs of physical damage, unusual noises, overheating, etc. 3. Replace the drive * if smart data or physical inspection indicates a hardware failure, the drive should be replaced as soon as possible to prevent data loss. Permissions issues. If the read-only issue is limited to specific files or directories, it might be due to incorrect permissions. 1. Check file/directory permissions *, use lsl/path/to/file or lsld/path/to/directory to view permissions. 2. Change permissions * use chmod and chown to adjust permissions and ownership. *ma changes permissions, read, write, execute. *chown changes ownership, user and group. Example *. Important * be cautious when changing permissions, especially in system directories. Incorrect permissions can compromise security. Write protection switch, SD cards, USB drives. Ensure that the write protection switch on the SD card or USB drive is in the unlocked position. This is a simple physical switch that can be easily overlooked. System updates and configuration. Sometimes, updates or configuration changes can inadvertently alter file system behavior. Review recent system updates or configuration changes to see if they might be related to the read-only issue. Consult documentation or forums related to the specific software/update for potential solutions. 4. Preventing read-only file systems. Prevention is always better than cure. Here are some tips to minimize the risk of encountering read-only file systems. Proper shutdown. Always shut down the system cleanly using the appropriate command, sudo shutdown hnow or sudo reboot. Abrupt power outages can corrupt file systems. Regular backups. Regularly back up your important data to an external drive or cloud storage to protect against data loss in case of drive failure. Smart monitoring. Regularly monitor the health of your hard drives using smart tools. Avoid overfilling disks. Keep your file systems at least partially empty, ideally 10 to 20% free, to allow for temporary file creation and optimal performance. Safe removal of USB drives/SD cards. Always properly unmount USB drives and SD cards before physically removing them. Clean system. Keep your system free from unnecessary software and regularly clean up temporary files to maintain optimal performance and reduce the risk of errors. Code examples, Python. While the core resolution often involves command line tools, you can use scripting languages like Python to automate some of the tasks. Explanation of Python code. 1. Check _read _only, mount _point, executes the mount command and uses grep, via Python subprocess, to determine if the specified mount _point is mounted with the RO option. 2. Remount _rw, mount _point, executes the sudo mount o remount rw command to attempt to remount the file system in read-write mode. 3. Run _fsck, device, executes the sudo fscky command to run a file system check on the specified device. 4. Error handling. The subprocess.run commands use check equals true to raise an exception if the command returns a non-zero exit code, indicating an error. Try, except blocks are used to catch these exceptions and handle them gracefully. 5. Requires root. The script requires root privileges to execute mount and fsck. You'll likely need to run it with sudo python your_script.py. 6. Automated fsck/remount. The script attempts to unmount, if necessary, run fsck, and then remount the file system automatically, providing a more automated solution. 7. Write test. The final part of the script attempts to write to a file on the potentially read-only file system to verify if the resolution was successful. Important considerations for code. Security when using sub-process to execute shell commands, be extremely careful about command injection vulnerabilities. Avoid directly embedding user-provided input into shell commands. Use proper escaping and sanitization techniques. Error handling implement robust error handling to catch exceptions and log errors. This is crucial for debugging and troubleshooting. User input validation validate any user-provided input, example mount points, device names, to prevent unexpected behavior or security issues. Root privileges ensure the script is run with appropriate root privileges, using sudo, when necessary. Consider using Python's os.getUID function to check if the script is running as root. File system type the fsck command and related tools might need to be adjusted based on the specific file system type, example fsck.ext4, fsck.xfs. 6. Advanced troubleshooting. If the standard solutions don't work, you might need to delve into more advanced troubleshooting techniques. Kernel debugging if you suspect a kernel bug, you can try enabling kernel debugging features to gather more information. This often involves recompiling the kernel with specific debugging options. File system specific tools some file systems have specific troubleshooting tools that can provide more detailed information about their internal state. Consult the documentation for your file system. Hardware diagnostics run more comprehensive hardware diagnostics to rule out any underlying hardware issues. Data recovery if the file system is severely damaged, you might need to resort to data recovery tools to retrieve your data. This can be a complex and time-consuming process. 7. Conclusion. Resolving read-only file system issues requires a systematic approach. Understanding the possible causes, accurately identifying the problem, and applying the appropriate solution are key to restoring normal file system functionality. The Python code examples provided offer a starting point for automating some of the troubleshooting and resolution steps, but remember to prioritize security and error handling when developing such scripts. By following the steps outlined in this tutorial, you can effectively diagnose and resolve read-only file system problems, ensuring the stability and integrity of your data. Remember to always back up your important data before attempting any major file system modifications.